Good morning and welcome to NASA's Kennedy Space Center in Florida, where we're here today to talk with researchers and scientists who are excited because they are about to deliver some of their important research to the International Space Station aboard the SpaceX CRS-4 mission that's slated to launch on Saturday morning. I'd like to introduce our folks who are here to talk with you today. To my left is Dwayne Ratliff, the Chief Operating Officer for CASIS. To his left, Mike Yagley, Director of Research and Testing for Cobra Puma Golf. Next, Dr. Eugene Boland, Chief Scientist for TechShot. Jason Gilbert, Scientific Associate for Novartis Institutes for Biomedical Research. Lee Werkheiser, Project Manager for 3D Printing in Zero-G. Welcome, everyone. We kind of would like to encourage just an open discussion this morning. We have a number of our news media folks in the room, as well as social media attendees for the NASA Social, and just kind of would like to have a dialogue about everything that's going on. Jason, for Novartis, this is part of a potentially ongoing investigation, and wondered if you could tell us a little bit more about the role of Novartis.
Sure. So I work for Novartis Institute of Biomedical Research in the Kadena lab, and for us, it's all about muscle. That's what we're concerned with, muscle mass and muscle function, and more specifically preserving muscle mass and muscle function. So we've got this great opportunity to send an experiment into a unique environment where, because of the microgravity, muscle mass is directly affected. So what we'll be doing is sending control samples up with normal functioning proteins, and then sending up a knockout sample that has MRF protein knocked out and not functioning. Now MRF is really cool. It's a muscle ring finger protein, and it labels other proteins for degradation and destruction. So when MRF is active in a muscle that's in an environment that is set up to get smaller, that's what MRF does. It labels proteins and they get destroyed. So what we're really hoping to see is, in the knockouts, situation where the muscle is actually spared from this atrophy in space. Now, why is muscle important? Well, unfortunately, we're all getting older, and once you reach about 65, naturally muscle mass starts to decline. This is also made worse by sickness, things like cancer, cachexia, or bed rest. So for us, maintaining a person's muscle mass is really important in these situations, because it will lead to a better quality of life and maybe a faster recovery. So we're really looking forward to this exciting opportunity to explore different methods and mechanisms behind muscle loss and how this could potentially help patients in the future.
Ken Kramer for America Space. For Novartis, I'm wondering, is this your first experiment on the ISS? Do you have others? What are your plans for the future? And your research will help not just people on the ground, but do you expect it to have applicability to the astronauts and perhaps long-duration space flight? Thanks.
Absolutely. So this is my first involvement in an experiment. I can't speak to whether or not we've conducted others, but for our muscle group, this is absolutely the first one for us. And in terms of applications for space travel, I think we're really excited about the opportunity to be in an environment where muscle atrophy occurs. I spend a lot of my time in the lab creating artificially muscle atrophy. So to be able to get data from a research station that happens naturally, it's very exciting for us, because it will really lead to some sort of future understandings that maybe perhaps through our artificial creation on Earth we don't necessarily catch or observe. But I do see sort of not just a patient benefit on Earth, but for long-term manned space flight, it's definitely going to be something that, muscle loss and bone loss will definitely need to be something that's addressed. And hopefully, this is the first step in starting to answer some of those questions.